Hello, everybody. This is Greg J. Got Neil, Shockwave, and Andy here. And we'll get to talking, but first we're going to watch a Thunderbolts video on the Atlas, 3i Atlas comet, and then we'll have commentary. Hope you're having a good night. Enjoy this show.
Both interstellar visitors, 3i Atlas and Swan, remain moving targets. Their unpredictability has fueled waves of speculation and no shortage of clickbait. In this video, we'll set aside the noise and focus on what has been firmly observed so far, with particular attention to the anomalies that challenge the standard dirty snowball comet model. As of 30th of September 2025, here is where things stand. In July 2025, astronomers detected a remarkable interstellar visitor, 3i Atlas. First identified by the Atlas telescope, its designation marks it as the third interstellar object ever discovered. From the very beginning, its behaviour defied expectations. It brightened rapidly, revealed a strikingly unusual morphology, and even appeared to eject material toward the Sun, a phenomenon that classical comet theory finds difficult, if not impossible, to explain. Mainstream models based on the dirty snowball hypothesis predict that cometary activity should be dominated by sublimation. Ice is heating and venting as they approach the Sun. Yet 3i Atlas consistently violates these assumptions. For proponents of the electric universe EU model, however, such anomalies are not contradictions, but opportunities to observe plasma physics in action. This object is expected to reach perihelion, its closest approach to the Sun, on October the 29th, 2025, and pass within 1.8 AU, roughly 270 million kilometers of Earth, on December the 19th. Close enough for detailed observation, yet distant enough to pose no threat, 3i Atlas provides a rare window into the behavior of an interstellar comet in real time. The anomalies of 3i Atlas. Observers have catalogued several features that challenge classical cometary expectations. Firstly, a sun-facing plume. Dust and gas extend toward the Sun, where thermal sublimation should be minimal. Secondly, a CO2-dominated coma. Observations from SPHEREX and JWST reveal unusually high CO2 relative to water. This ratio is rare even among solar system comets, suggesting a fundamentally different chemistry or an alternative process at work. Thirdly, rapid brightening. Sudden increases in activity and changing coma morphology occur unpredictably as the comet nears the Sun. And fourth, non-gravitational accelerations. Jets, dust motions and fragmentations are inconsistent with sublimation-driven thrust models. Each of these anomalies highlights the limitations of conventional cometary theory, while simultaneously providing a rich dataset for EU model analysis. Electric comets, a conceptual overview. In the electric universe framework, comets are not just icy bodies, but electrically charged objects interacting with heliospheric plasma, the Sun's electric field, and surrounding currents. Electrical currents flowing between the comet and the Sun produce glowing discharges, focused jets, and plasma sheaths that shape both the coma and the tail. A striking example comes from NASA's Deep Impact mission to Comet Tempel 1 in 2005. While Thornhill and other EU proponents have long argued that the narrow filament-like jets, high-temperature hotspots and sharply sculpted surfaces observed by spacecraft are far more consistent with plasma discharges than with sublimation alone. Tempel 1 revealed phenomena that make perfect sense under the electrical model, yet remain puzzling under the traditional icy snowball view. For example, the coma's shape reflects electromagnetic forces, not just gas dynamics, allowing sunward plumes and anti-solar tails to coexist. Volatile release can be electrically stimulated rather than solely thermally driven, explaining unusual gas compositions and unexpected timing. Viewed through this lens, 3I Atlas's unusual features, its sunward glow, rapid brightening, and CO2-dominated emissions, are not anomalies but natural consequences of electrical interactions with the surrounding plasma. The sunward glow. Hubble images revealed a dramatic plume stretching toward the sun, 10 times longer in that direction than across. Harvard astronomer Avi Loeb described this as, quote, unprecedented. Why does this matter? Well, according to the standard comet theory, such a feature should not exist. Dust and gas are supposed to be pushed away from the sun, sculpted by radiation pressure and the solar wind. A sunward plume is, within the classical framework, impossible. Within the electric universe model, this is exactly what we should expect. An electrically charged nucleus immersed in the heliospheric plasma develops asymmetric discharges concentrated on the sunlit side. Charged particles then accelerate along local electric fields, guided by the comet's fluctuating charge and its current pathways into the surrounding plasma. The outcome? A brilliant sunward-facing plume alongside the traditional anti-solar tail. Polarimetry, dust under the light. Polarimetry, measuring how light is polarized, reveals the secret of cometary dust. 3I Atlas shows an unusually deep, narrow negative polarization branch. The angles and minima point to large grains made of ice mixed with dark, absorbing material. In the electric universe view, grains with different conductivity respond in unique ways to charging, acceleration, and plasma currents. This produces the complex polarization patterns we see, patterns that the classical sublimation model struggled to explain. Even 2I Borisov, the first interstellar comet studied in detail, showed similar properties, though less extreme than 3I Atlas. Together, these observations suggest that interstellar visitors carry dust and ice in arrangements that naturally produce electrical effects conventional models do not predict. Carbon dioxide dominance explained electrically. The CO2-rich coma of 3I Atlas overturns classical expectations. In solar system comets, water usually dominates near perihelion, with CO2 making up only 10 to 20% by comparison. But SPHERE-X and JWST observations show CO2 rivaling or even exceeding water in this interstellar visitor. In the electric universe view, electrical discharges on the nucleus can liberate CO2 far more efficiently than sunlight alone, producing asymmetric plumes at unexpected ratios without invoking exotic ice chemistry. The comet's changing colour strengthens this interpretation. As 3I Atlas brightened, it shifted from bluish hues to a vivid green, the hallmark of carbon molecules excited under electrical stress. Rather than a chemical oddity, this glow is diagnostic, a predictable consequence of a charged body interacting with the heliospheric plasma. Non-gravitational accelerations. Classical comet theory often invokes sublimation-driven jets to explain orbital deviations, yet 3I Atlas exhibits accelerations inconsistent with simple outgassing. The EU model provides a natural explanation. Charged dust and ions accelerated by local electric fields produce the observed motion, acting as a cosmic thruster. Abrupt brightening episodes and filamentary jets follow naturally from plasma interactions, rather than improbable sublimation events. Equally, these can also explain anomalous slowing. The alien gap fill. When mainstream models falter, the void is often filled with speculation about aliens or exotic technology. Some commentators even claimed that the sun-facing plume of 3I Atlas might be artificial illumination, a stretch that betrays desperation more than insight. To be fair, anomalies abound. 3I Atlas also carries an unusually high bulk density and a peculiar nickel-to-iron ratio, both of which pose serious problems for the dirty snowball hypothesis. An object supposedly made of fragile ice and dust should not register such compactness, nor should its metallic signature depart so sharply from solar system comets. These features alone have invited speculation that goes beyond nature. As Harvard astronomer Avi Loeb has provocatively noted, quote, "Perhaps it is natural, but we have to allow for the possibility that it is technological," end quote. Where others see science fiction, the electric universe model sees physics. Plasma interactions, electric fields and heliospheric currents offer natural, testable mechanisms for the very signatures driving alien speculation. Loeb's cautionary what-if may grab headlines, but the EU perspective provides the sober alternative. Comets as active electrical bodies, not interstellar spacecraft. Velikovsky's cometary legacy. In 1950, after an extensive study of mythological sources, Immanuel Velikovsky proposed that Venus entered the solar system as a comet, possibly ejected from Jupiter or Saturn, and only recently settled into its current orbit. Critics, adhering to the view of a stable, slowly evolving solar system, dismissed his ideas as pseudoscience. Yet, he predicted two specific outcomes. 1. Venus would have an extremely high surface temperature, and 2. Its atmosphere would be dominated by carbon dioxide. Decades later, both predictions were confirmed by space probes. Similarly, Thornhill's electric comet model anticipated features such as filamentary jets, rapid brightening, sunward plumes, and unusual volatile composition long before conventional theory offered explanations. Rapid brightening, electrical avalanche. Classical explanations blame sudden exposure of volatile ices or phase changes. The EU model, by contrast, points to electrical thresholds. As a comet moves into regions of higher heliospheric potential, currents build. Once a critical threshold is crossed, an electrical discharge, an avalanche, ignites surface material, blasting dust and gas into space. 3i Atlas has recently displayed just such behaviour, its brightness surging while its colour shifted to a vivid green. In the EU view, this glow signals the excitation of carbon-bearing molecules under electrical stress, a hallmark of active plasma processes. These outbursts can repeat, appear asymmetric, and form coherent, long-reaching jets, all patterns that classical gas dynamics struggles to explain. The Deep Impact debacle. Before NASA's Deep Impact mission slammed a copper projectile into Comet Tempel 1 in 2005, while Thornhill issued several specific predictions based on the electric comet hypothesis. He stated that the resulting crater would be far smaller than expected, and that a brilliant flash, electrical in nature, would occur before the projectile actually struck the surface. Outcomes directly at odds with the dirty snowball model. When events unfolded exactly as Thornhill described, NASA scientists were visibly stunned. One confessed on camera, quote, "I'm at a loss to explain it." Matt Finn revisits this in the Thunderbolts episode, Set the Record Straight, showing how the mission inadvertently validated key aspects of the EU electric comet model. As Thornhill observed, quote, "All the things we see around comets fit the electrical model, but don't make much sense in terms of icy snowballs sublimating into space," end quote. And in a remark that has only grown more prophetic with time, Thornhill added, quote, "It is surprising that they continue to be surprised by all the surprises," end quote. 3i Atlas as a live test. If 3i Atlas is electrically active, we can predict evolving coma morphology tied to heliospheric voltage, episodic surges of carbon dioxide and other volatiles, filamentary jets, rapid outbursts, and possible fragmentation, all driven by electrical erosion rather than thermal effects. These predictions are testable with spectroscopy, radio to optical imaging, and plasma diagnostics. Timing of activity relative to heliospheric field changes can confirm electrical interaction rather than mere heliocentric distance. A newcomer joins the stage, Comet Swan. The sudden arrival of Comet C 2025 R2 Swan has sharpened the mystery. First detected in September 2025 by the SOHO spacecraft's Swan instrument, it appeared almost out of nowhere. Already bright and already active, it reached perihelion scarcely hours after discovery, By then, it carried a fully developed tail and a luminosity that slipped neatly through the fingers of sublimation theory. Its path takes it close, perihelion at roughly 0.5 AU on September the 12th, and Earth's closest approach near 0.26 AU in October. With a long period orbit stretching tens of thousands of years, Swan is a true wanderer from deep space. Yet, in its behaviour, it mirrors 3I Atlas: sudden ignition, volatile outbursts, and a plasma-dominated tail. Signatures of electrical processes that conventional models struggle to explain. Mainstream voices dismiss such anomalies as coincidences, isolated quirks. But a pattern is emerging, and with it, cautious concern. Are we witnessing a chance alignment of two unusual comets? Or could they be fragments of a larger hidden swarm now drifting into the inner solar system? If the latter, the consequences could extend beyond astronomy. Is Comet Swan part of a hidden swarm? Electrically active comets can disturb the solar plasma environment, provoking outbursts from the Sun. On Earth, such changes might cascade through the magnetosphere, producing intense auroras, temporary disruptions to satellites and power grids, and, as some studies cautiously suggest, correlations with heightened seismic or volcanic activity. What we are witnessing may be a small window into a larger, electrically dynamic environment in which comets, the Sun, and our planet are more closely connected than previously imagined. Similarities and differences. Swan vis-a-vis 3I Atlas. Both comets undermine the dirty snowball model. Swan brightened abruptly near perihelion, its sudden activity pointing to electrical processes as much as solar heating. 3I Atlas showed the same kind of behaviour, becoming luminous only when discharge activity began. The differences, however, are key. Swan passed much closer to the Sun, where heating effects were stronger, and its near approach to Earth gave astronomers detailed views of its tail and plasma structures. 3I Atlas, by contrast, was monitored for months before it reached the inner solar system, revealing electrical activity at great distances, well beyond the reach of solar heat. This distinction highlights why Swan's late discovery leaves open questions, while 3I Atlas provides clear evidence of electrical activation far from the Sun. Why these visitors matter. 3I Atlas offered something unprecedented, an interstellar sample observed in real time, with chemistry, morphology, and dynamics that defied every expectation. Sunward plumes, polarimetric signatures, non-gravitational accelerations, rapid brightening, and CO2 dominance all reflected the behaviours long predicted by the electric universe model. Now, with the arrival of Swan, the pattern is reinforced. The significance of these comets lies not in their individuality, but in their shared defiance of conventional expectations. One anomaly may be dismissed, two form a pattern, and in science, patterns demand attention. The electric universe does not label them anomalies, it sees evidence. Together, 3I Atlas and Swan pose a question that mainstream astronomy has struggled to confront. What if comets are not inert leftovers, but active participants in a charged solar system? What if their behaviour is not random, but electrical? If so, the dirty snowball model is not so much incomplete, it's obsolete.
Alright, well that was the video Thunderbolts put out recently, and here to help explain a little more and expand, I have Neil, Shockwave, and Andy on board. Hey Neil.
Hey.
Are you there?
I am indeed.
Okay. I'm going to try to turn you up a little bit. You're a little low. Okay. Talk now.
I am?
Yeah,
Sorry.
You're okay now.
Closer to the mic.
Yes, indeed. Yes.
I turned you up.
Stop being so relaxed.
It's been a long time since we've talked. How you been?
Oh, well, life has been a bit lifelike. Obviously, of well, I guess you could say we always lose people.
Yeah, I know. Yeah, just
I was thinking, I just noticed Wall up there too. But if it wasn't for my dad, however, I wouldn't even be here. I mean, not in that sense, but I mean, in a very much in a science sense. As much as I don't want to give Graham Hancock any credit for much of anything.
Yeah, I'm with you on that.
Well, I'm not. I shouldn't chastise anyone looking for the truth. Okay, but I mean, you can follow the pop culture to where it is. However, I will give the fact that just 1,000 more eyes with cell phones have dropped over the pyramid complexes and such. It has been amazing to see what they've revealed. An example, we'll probably have to talk about sometime, actually, would be just the simple. Go ahead.
I'd like to interject. Graham Hancock's not wrong when he points out that there are cities under the water along the continental shelf of the continents.
No.
But he calls them advanced alien, not advanced cultures. Advanced civilization that preceded our civilization. I don't think that is quite the case. They may be 1500s, 1800s, around that era, kind of level of technology. But it was a different kind of technology than what we have today and what we had back then too. It's more naturally based.
I've thought about it for a long time, and I understand now even how those scoop marks are made. So it's possible. And when I realized that that's the technology that they used, I realized that these were technologically advanced people, at least with regards to chemistry. And chemistry, of course, the word alone, the land of Kemet, and alchemy, of course, and of course combine those two together, and it's just a matter of chemicals and lying over top of metals before you invent a battery. However, I'm not really referring to that type of thing, but I wanted to say that I gave credit that he inspired me to go looking, but his pop culture version has also opened up real things. When I was watching him in the 1990s, he was talking about degrees of where things are on the planet and stuff, and I was like, whoa, this looks like a real big conspiracy, and I thought it was fantastic. Now, I bought the book, Fingerprints of the Gods, I think it was, or something, and and my dad and I talked about that. Now, when I did also research into that, I also realized that he was unconsciously and not knowing, so I'm not blaming anyone. He began to understand, or he was basically following in the footsteps of what's called the Vril Society, which is the like in your head, okay, when you say advanced technology from Atlantis, everyone thinks white people, and so did the Nazis. That's where the Vril Society is from, by the way. It's a eugenics cult, okay, where you're supposed to trace back to these perfect people. It's sort of like, not unlike Scientology, where do you have a magical dead being inside of you, type shit. Don't get me wrong, I'm not chastising anyone for following, but just it's like not knowing that the globalist conspiracy is just the international Jewish conspiracy. It's that type of thing, just with a new label put on top. Don't get me wrong. I'm not saying that anyone who follows the conspiracy or understands global affairs and has questions about it might not see some sinister actions. So I can't argue with that. But what I'm saying is that's irrelevant to the fact that it's that same type of thing where there's some little evil force of people with deep pockets and little fingers that are getting in fucking with your life. That's the kind of mentality. That's all I'm saying. So I'm not chastising either of them. No. Well, no. I'm simply saying don't let that discourage you, because a lot of things have come from, I mean, just the idea of a bunch of people who believe that they are going to find something amazing in Egypt don't know what they've been filming, and filming it in high definition. And the things that we have, the things that I have learned just in the last, compared to what books taught me, like I used to have to find this stuff literally in like Reader's Digest books, Mysteries of the Unexplained, a giant table book, thud, you know? Oh, yeah. So I mean, the internet's been amazing. So I'm not chastising anyone for these wonderful ideas. Just you should remember where they come from. Even the pop culture versions are not the same, by the way. Like I can't speak for the globalist international Jewish one. Like that's just something I threw in there. But with regards to science, the idea then that he was basically advocating the same thing, not knowingly. Well, that's understandable because it's very provocative. Chariots of the Gods, you know, we can go back all the way to the 60s and talk about this. Velikovsky. You can go further than that into, of course, you know, what did, I think they were called the Hichi that lived on Venus in the books made by Arthur C. Clarke. And what they thought was under the clouds in the 1950s, before the Venera probes got there. And they realized, holy crap, you're going to die. Like anything, I mean, the first probe only lasted 15 minutes, if I'm not mistaken.
Yeah, it was a very short time span that the Soviets had to gather data.
Well, that on the first one. By the second one lasted about an hour and a half.
2 hours. Yeah, almost
something like that. Yeah.
Why is it you suppose they seem to have the same, Omal and Atlas have the same shape? Because it's really uncommon for a comet.
We don't know what the shape of Atlas is. Nobody has been able to see the shape of it. I don't think. So I don't think they've turned the radars onto it yet and peered through the comet yet.
Actually, let me be frank, or Ernest, one of those two names. The shape of a comet is inferred by its change in reflectivity and luminosity as it goes around the sun, suspecting, of course, this is the same way that we determined, for example, that Charon was a moon of Pluto. And it wasn't until we went flying by in the ESA spacecraft that we realized that Pluto had 5 moons.
Okay, so what you're saying is what we're looking at is an artist rendering.
Yes. And of course, as you can tell, since we are, let me be clear, I'm not lying when I say this, we are always wrong. We have never been right, ever, when we've gone to another planet.
That
ever.
Would surprise me.
Like, I mean, it was 1950 something, and it was Velikovsky who made the prediction that it would be hot. he didn't understand how much pressure there would be because it was pulling. The argument, of course, is that Titan and Titan and Venus were birthed at the same time. They were. This is, of course, an inference by. I don't think it was John Cook, but let's not. I apologize, whoever did come up with this, that I'm stealing now. And if no one else did, then I did. Yay. Could be Eduardo. I don't know. The point is, though, is that most of the time when these things are born in this way, and this is a good understanding of the forces involved and what we're looking at. Most of the people, actually, this is pretty good on the screen, they're thinking of things like the plane of the ecliptic, that's Pluto with the orbit going around, on the angle. So, but that's not at all what it is. It's best to think of each body is itself a charged body, and the sun itself has a charge. And the if you could think of them as like a hill, and the entire atmosphere of the sun, like the solar wind atmosphere, is like a bunch of waves, water flowing away from the sun, and then it is crashing into these are charged particles, of course, but in the essence, this is a combination of electric and magnetic and capacitive effects. So basically, you only have so many ways to store energy, by the way. And let me just break it down. You could have a power source that is definitely involved. For example, nuclear reactions are on the surface of the sun. Every lightning bolt creates one. So a minor one, at least. But obviously, the idea then that electrical reactions can cause radiative effects and death is real. Just in case you were wondering why, why did people go to the north to try to get towards this thing that was sticking out of the top of the planet? Well, yeah, that would be great, but you're never coming back. The radiation that's coming from those toruses is going to fry you. Like when you get close enough to it. It's incredibly powerful. Now, so the sun, of course, being the large object that is interacting, by the way, with it's getting its energy outside of this system. So the energy for the solar system itself is coming from not the rotational effects. I mean, that was probably initiated by that, but inertia and gravity are real. Just straight up. But if you think about them, that this water in each of these charged bodies also, its mass is sort of like holding it where it is and keeping its rotation, but it also has a potential based on where it is from the sun. The more it lights up, the more things are out of balance. So we light up. There's lightning all over the earth. We're not where we're supposed to be. Clearly. We've moved.
Oh, we're moving every day, right? I mean, every minute.
No, I mean, we've moved our orbit.
Oh.
Like the potential of that's an indication of movement. Another one would be Io. Io is electrically being etched all the time, but Europa isn't. So Europa is probably where it should be, or where it's now in balance. But there's no such thing for Io is still chilling out because it's covered in sulfur and it's electrically being etched. I mean, there's a wall, like a cliff face, and they think it's lava at the base of it or whatever, but it's not. It's electrical, and when they went by it the first time they took a picture of it, and they went by it again 5 years later with this ESA vehicle on its way to Jupiter or Pluto or whatever. And taking a look at it again, it went back 5 miles. So it had receded. It's like, think of it like Niagara Falls. In 5 years, it went 5 miles. A mile a year has this cliff face disappeared. Straight like cliff, just gone. And it went back 5 miles. So all that material, which is many square miles of material of a cliff that's probably like a mile or 2 miles tall. I'm saying miles, but I'm using these approximate things anyway. So these processes are still are still happening on planets all the time, like the plumes of Enceladus and
you see all that material being umbrellaed in the shape of an umbrella, pushed out to the down to the surface of the moon itself.
Well, that's a low level effect, yes.
Yeah, and it's not. I'm sure that some of the material is escaping into space, but a lot of it is being pulled back down to the surface of the moon,
or to another body.
Well, another body. There is no other body. It's just Io there.
No. What I meant was is that if you've looked at pictures of Pluto or Ioanopus or other planets, even moons, even Europa, you can see that sometimes they're covered with dirt on top of ice.
You mean Iapetus?
Thank you. Oedipus?
Yes, you're welcome.
Well, I'm not even sure what the hell I was saying. Yeah, we're having good times. Let's play around with that for a while. Yeah. Here is something though. Oh,
mispronunciations drive me nuts.
Well, let's.
So, what is your take on the heliospheric currents they recently discovered?
I already knew they were there before.
Yeah. Electricity in space, right?
Well, yes. This is these, like the currents going into the north and south of the sun, they're real, and the outflow is along the ecliptic. This structure, which is from the magnetic field of the sun. Why is it there? Well, there's iron on the sun, and that condenses magnetic fields. Why is there iron on the sun? Well, that's actually straight up. There's iron in the sun because nuclear reactions that occur on the surface of the sun will burn things down until they hit iron. That's the last gauge.
Right.
So, yeah. And then so obviously, if you're the largest body in a system, in the electric model, as far as I know, we cannot necessarily tell for sure the material a body is made of. It's irrespective of, like, its apparent mass is not its real mass. They said that about Atlas when it came by. They said it was heavy, like Oumuamua. And they determined that by its orbit and how big it, like, basically how big should it be? What's its mass should it be? And notice that when some comets come in, they say, oh, well, it's only like 10 tons. It won't do much. Well, it had to be 10,000 tons. Why? Because of the power that came from it when it exploded, because they only have kinetics. But as I said, there's a way in electricity. There's one of them on the screen right there, that magnetic pinch effect. But in a magnetic field, you can store energy. So if you think of every magnetic field that a planet or planets have, it stores energy. Okay.
Okay.
So it's called the inductor. Basically, they tend to slow down current like they resist changes in current. That's the biggest thing. So this is, for example, what you're looking at right there, these magnetic field lines. I was about to mention something about the local chimney. We are stuck to something like that on the side of one of those. That's where we, the solar system, is getting all of its power. And there is a planet further out, or there's a solar system further out, the Proxima Centauri 4 light years away, that is attached to another shell, we could call, of the, like, we're like little pinches along the shell of a Birkeland current. We're not even in the center. The center of this pinch is the Pleiades and Sirius. They're both in the middle.
Say, yeah, the Pleiades plays a huge role. I think we're even orbiting the Pleiades.
Well, we know that this happened. The Pleiades exploded. It was the whirlpool of antiquity, where the Argo went down the whirlpool and came back up. This wave was approaching us, by the way. The explosion of the Seven Sisters, as it were. Now, this was heading. This was a field that had exploded, and basically, it's not really heading towards us, but the electricity of it was, and that, for example, leaving everything else out. If you don't even believe that planets could move around like this, that effect would have an effect on the solar system. Everything would begin to glow.
Yeah.
So that could have been something that occurred, perhaps further.
A dump of energy into the solar system from another solar system.
But it's clear what had occurred. This is actually really a good depiction of how you cannot see. You cannot see a Birkeland current.
No, but they have left remnants on the Earth, such as the Eye of Africa.
Oh, of course, yes.
Yeah,
100%.
Yeah.
Yeah, it's actually.
Well, we see filaments that are in glow mode. That's a Birkeland current.
No, I meant on the screen. Those are the magnetic field vectors. But if you also note that there is a magnetic field vector on the opposite side, if you're looking at it, you have an exact zero sum on both sides. That's why you can't see a Birkeland current because everything nulls out.
Right.
But anyway, what I meant, well, if you think about this as the local chimney, then you can see that we are on one of these lines, maybe let's say the yellow one, and the green one is, that's where Proxima Centauri is. And the red one in the middle, that was right where Sirius and the Pleiades were. So they're getting the most current. They have to, and remember, it's not to an electrical situation, it's a load. It's each galaxy is a light bulb, or let's just go with solar systems. Yeah, the solar system is like a pinch, yes. The whole thing. And obviously the Pleiades, there's 7 stars there. There could have just been one star there that blew into 7 pieces. Okay, that's the same thing as why Betelgeuse is going through this weird thing, and people think it's freaky. It's going from glow mode to dark or to arc mode. So they
think they found a companion for Betelgeuse now.
Well, of course they're going to find companions.
No, a companion star.
No, I'm agreeing with you. But of course they're going to find that, because if I say it's going to arc mode, that means the current is going up. But the shell that we're seeing that makes it a giant is not really true. The giant is just the solar system glowing in a glow mode. And the planets are inside of it going around the sun, which whatever that size really is. And it starts retreating as it goes into arc mode. That means that other bodies in the system have to begin to glow to process the extra electricity. If that makes
Right,
sense.
well, yeah, it does. But I'm referring to what NASA just put out recently about an object orbiting outside of Betelgeuse and causing its very long cycle. It has 2 cycles, a short cycle and a long cycle. And this parent object orbiting it is causing the long cycle.
Well, I have no doubt that they're not that this is accurate, but it is what is expected. If like you should see it begin to glow as the glow mode goes away, and the current has to be processed, so other bodies will begin to process that.
Yeah,
and they can do it for different ways. Now, let me show you. Can you see my screen, Jay?
Let me see if I can.
Sure.
Hold on 1 second.
I was just going to tell you about 3i Atlas so that we can at least understand what we're looking at here.
Yeah. How do I see your screen?
Just double click on my name or
Okay, hold on.
in the Discord.
All right.
And it should pop up, and you can take it out or however you would normally do it. Or I could just link you these pictures, but
well, I don't see your screen. I just see your account.
No, my name.
Click on your name. Okay, APOC one.
Yeah, just double click on it and it should pop up.
Not what do you have in it? I don't see anything.
Michael Claridge?
Yeah, that's what I have right now, but I'm trying to.
No. On my screen.
Okay.
He's saying he has the Michael Claridge video up on his screen. If you switch to his screen,
okay,
it should pick up.
I'll put mine on it. There you go. So you see mine. There it is.
How do I find it?
Just double click on my name.
I did.
Yeah,
just on top of your name.
Okay, I got it. All right. I'm putting it on your. Is it? Okay, I see it. Okay, we got it. Now I'm just gonna have to take it and see if I can get OBS to go over there.
Oh no! You can actually just take. I think you can pop it out. I think there's an option to pop out the window, and you can drag it over. But I don't know.
Okay, hold on a second here.
If you can't, that's fine.
Well, I'm just trying to figure out. Okay, pop it out where I double click it. No.
Well, I think make it its own little window, but.
Okay, hold on. I'm making strides here. Just a second.
No problem.
All right, so I'll try to put it in my window here. Server. There it is. Okay, I got it. Yeah.
Okay.
Yeah, got it.
Okay, so it should.
It's done.
Well, yes, but I'm just waiting for it to appear on the stream.
Oh, it takes about 30 seconds.
Oh.
Yeah, you should see it anytime.
It's up now.
Yeah.
Perfect. All right. Well, I suddenly went into a sneezing fit. I apologize there.
It's okay.
So, when I saw this, Michael Claridge does some wonderful pictures. So, just so that you could begin to understand that this is like a river or field, the sun in the middle, the Earth is going around. You have these. He's depicting currents, but he's also depicting the magnetic field and showing you this disc thing that you see coming out of the Earth here. This little dot, black dot there. Well, that is the Van Allen belts around it. The magnetic field itself is you can see that the positives would wear away at the middle of the planet, or the middle, which is true. This is why you get these barbell shapes. But in the comments, I mean.
Yeah.
But in your but this is also a homopolar motor. And if you notice, it has inductance, it has a resistance, and of course, it has capacitance. So when we're looking at capacitance, in my little video here, I showed like what happens when plates move, and what are the forces involved in just this little boundary here between the Earth and the ground. Well, if you think about each comet, whatever it is, so this thing coming from Oumuamua or whatever, this is why I don't think the elongated shape is probably accurate. I think it has brightening and darkening because, of course, of the plumes coming out of it. You can see these plumes right here in the aurora. Like, it's the same thing, except that it doesn't get close to the Earth because the Earth actually has a charge on the inside of it that keeps it from that layer, a positive charge, from getting to it.
A double layer. Say it.
Yeah, it's a double layer, but it's also a capacitor, and it holds energy. And when you start piercing it with rocks, this works on the but it's easier to understand on a planet because I don't want to get into the forces there for you guys, but you can see that anything that's positive, that's pushing down from the top, whether in a plume or whatever, from the sun or anything, it'll affect this. It'll push down on the plate on the top, which means a bunch of negative charges go to the middle, and that attracts the plate on the bottom, or vice versa. So this would also happen if there was no plume and it was a giant earthquake. We note that happened in that 2004 there. But so you can see, like, here's this positive charge being pushed away by, and as soon as it enters, if it's not that big, it'll just glow, have a tail, and hit the ground.
Yeah.
But if it comes in and actually begins to have a bigger effect, like, it's not a circle. That's the biggest thing. It's never been put under this electrical stress. And when I say electrical stress, you got to think of it like, maybe pressure is a good way of saying it. This is from this little positive dot is like based like an asteroid in the asteroid belt. And suddenly it's coming towards us for some reason. And as soon as it starts coming in, it's going to have this, like anything that's pointy that's sticking out of it, because it's not a circle, but the positive core is in the center. So the positive core being in the very, very center will cause anything on the top to be shaved off. This is what the Earth is doing with lightning all the time, and just shaving off everything till it's the same level as the water. That's what it would like. And it will just start dumping dust all over the middle of us forever, which is why we have the sand. No, that's okay. That's the way the planet's supposed to work. I mean, at least generally speaking. It's like a not really effective homopolar motor, but it stores energy very well. Like Michael Claridge described this, it just keeps pumping up the layers. I had a little, where was it? It charges up, like when he was showing that there's the voltage away from the Earth all the way to the ionosphere is one thing. But the Earth sits inside of the sun's environment, but they're not separate. It's like the same thing, but if you think about the charges like pressure, if something's under so much pressure, it keeps pushing and pushing these negative charges towards the surface. And as soon as the positive charges in the center touch the negative charges on the surface, it blows to pieces. It's a shotgun of charge. That likely happened. This is probably why the Earth is the way it is we were one of those shotgun charges that was suddenly then grabbed and pitched, put into a ball, but like a concretion.
Mm-hmm.
But in this sense, these are the waves that are going, and he notes that it's not just the wind going away. These are ripples like Alfvén waves coming from the sun, okay, that are being pushed along, and they're literally able to do work. And you can think about these ripples going over and over the shore, tearing chunks off and putting them into the air. Well, space. So they keep moving. They're just so this is of course then going into the Earth has its own thing. The sun has its own charge, but these bodies that are coming in, the reason they're so weird, like see, this is what he's noticing here. This is like all the processes. We can add more belts. Like the Earth suddenly gets a Van Allen belt and then another Van Allen belt because we're processing more charge, and we're keeping this away from, it's literally being kept away from the Earth, but it is moving charges within the Earth. And remember that the Earth itself does not have, like it's solid, and moving charges within it will cause stuff. Like that's why you can end up, let's say you're over in Spain and they have a power outage. Well, it could have been as simple as the charge, because like I just described, the charge got a lot of negative in the area because a blob of the Earth, like the solar whatever, came close to whatever. When it gets close, the blob of solar plasma or the rock or whatever it is gets close to the Earth, and those charges start coming up. They start, like, it's pushing down the ionosphere. So of course the charges start going are going to the center, and they pull up charges from the bottom. Well, all the negative charges suddenly make the difference between North America and Britain or wherever completely different charges. They no longer have the same zero, if you get my meaning, like the same ground. So with a voltage potential difference, they're going to shut off. Communications will drop because something's not zero. It can't connect to the other side of the planet because the other side of the planet's 3 voltages higher. I mean, it might not seem like much, but that's a lot.
Yeah.
I mean, especially when you're running at 5 volts. Now they're not, and there's a lot more to it than that. But you get my idea. And of course,
it's more dynamic. The telluric currents in the Earth are more dynamic than that.
Of course,
they're more localized than people realize.
Well, they no, that's not exactly true. They flow along disconformities, just like they flow along.
They're stronger in certain areas and weaker in other areas of, say, a 50-mile radius. They're stronger in one area, and it's flowing like waves, kind of thing.
Actually, I was about to say that. Yes, it's like a shoreline, except these charges are going along the rocks, where you have like a
I think they're going along the water.
Oh, that definitely. But no, I was referring to telluric currents, specifically referring to the idea of ley lines and earthquake lights.
Right. Okay. Gotcha.
And I think that's probably why that we have, like, if you've ever heard you've heard of the menhirs in France that are just long, giant stones that are just all put up, leading all the way towards Ireland or whatever.
Yeah.
And now, I just want to remind everybody that the solar wind is capable of etching comets. Charge on the Earth is also capable of breaking matter down into smaller particles, as witnessed by the thunderbolts of the gods, and Andy Hall's work with the supersonic updrafts and downdraft storms of the hurricanes and tornadoes that occurred in the North American continent.
Oh yes, I found that fascinating.
That stuff is awesome. But again, charge is capable of reorganizing matter from solid matter into particles, into plasma, even if it's a great enough charge. Carry on, Neil.
Well, you've reminded me just to mention that many of you might have heard of something called the Great Unconformity, or like, why are we missing so many, like a billion years of human history, or not human history, of history or whatever? Like,
Right.
why?
Uniformitarianism, yeah, we're missing a huge chunk.
Well, they say, oh, well, this was because of one of these ice ages or something. And like, no, okay, it's exactly what you said.
Yeah.
Everything that was on the Earth at that time was like gone. It was just ripped up and torn up and then dropped back down and sorted in different ways until it completely covered over what was here before. That's why we find parts like a dinosaur bone's not hard to find. I went and found 5 of them just walking around in Utah, and a geode. Pulled it right out of the rocks. I was like, oh, look, a geode. Like, they're everywhere. And those are all signs, of course, of electrical effects, because basically the reason that dinosaur bones are hard to find is not because of the conditions of blah, 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 blah. No. It's not the conditions. It's basically the reason that we don't find them with flesh on them is not because they died in a whatever. It was blown off. Like literally just torn right off their skeletons. And the fact that the skeleton would even be left, okay, is like amazing.
Yeah, well, I worked with stone porches and things like that, and so many times I've seen bits of metal and strange long shapes and weird shapes of metal in this sandstone that's been quarried off of the continent, and it has to be from the old civilization, and it just got ripped up and torn up and dumped into another place, and later on rock got created and we're using that rock.
Actually,
now.
I'm not even I can't attest to that. However, I can attest that once you start getting to metal, this is where things are a little bit different.
Well, my question is, how the hell does a piece of metal, like maybe like a wire piece or a bracket or something like that, something in that kind of shape or size, get into a piece of sandstone when gentle waves and is supposed to create breaking down of mountains, and you're supposed to create,
actually. Well, not that way. I mean, I can tell you right now how it happened.
So I'm just saying, I'm kind of like saying that that's not possible to find a chunk of like wire-like metal or a bracket-like metal contained within the sandstone. You know what I mean? It's
well,
not
uniformitarianism would require it to have been laid down whenever the sandstone would lay down, but my interpretation is somewhat
in an electric universe. It's allowed because it just those supersonic winds pull everything up and throw everything around.
It doesn't have to even be that complex. Let's just say you're sitting, it's specific, you were building a door beside a pond, or better yet, there was a house there. It fell down eventually. The door floated on the water for a while, became to rest. Eventually, most of the door rotted away. There's only a hinge left. The hinge is above the water line, but still damp in an area one day. And then there's a thunderstorm and it gets hit by lightning. And now it's a rock with a hinge in it. That's as simple as that. Doesn't have to be anything more complex.
Well, no, that's not what I'm talking about. I'm talking about.
No, I know.
Layers of sandstone that are being quarried. That's a different thing. That's a different thing.
Well, you said you were playing with them, so I pictured it was much more local. I apologize.
No, this is like, I'm talking about sandstone that comes from a quarry that we used to build porches with, or not sandstone, but
Well, I'm agreeing with you. I'm just simply saying that it can come from anywhere.
How does the metal get in there? Is what I'm saying. If it's a uniformitarianism, even in a storm, a heavy wash, metal isn't going to roll down and be deposited in this layer of sand and then be crushed into a stone.
Yeah, I always thought that uniformitarianism was needed for the Big Bang and evolution. They all need each other.
Evolution requires uniformitarianism.
Yeah. So I mean, if one gets shot down, that means it don't work.
Their theory of it.
Yeah.
Yes.
That's right.
I'm not disagreeing with the overall idea of what he's trying to understand with regards to the origin of species, but I don't think that's actually accurate. But let's not worry about
so either.
But let's not dwell. I mean, I don't think that. Anytime you say "and then millions and millions of years," you might as well say "and then God said" or "then the aliens did." They're all the same words.
Right.
They're fictional. They don't exist. They're just crap.
It's all theoretical.
Now, I have no idea. There is natural metals, so and obviously we can get these rare earth metals or any type of metals exist tons of different places. But let's not get into all of that right now. Let's just look at the why those four things happened to our friend as he went around the sun, the 3i Atlas. Well, this is if you can see, he's also talking about the currents going ahead. These are telluric currents that would flow around the planet. But the sun itself has, like I said, a stream, more electrical potential, lower as it goes further and further and further out from the sun. So this is 3i Atlas. It is supposed to be heavy. I attest that it is not heavy.
Probably just a rock.
Yeah, but it's charged.
But I think it's a rock, and it has a lot of metals in it because it's not giving off a proper tail. I think
you're wrong.
That it's metal.
No, I mean it might be metal. I think you're wrong though. Number one, because if it is metal and it's iron, then it's going to start generating its own magnetic field as it goes faster and faster through this, which I didn't see any plumes at the top and bottom. So let's just leave that alone for a moment.
No, there have been no plumes. The normal cometary tail pushes away from the sun with the solar wind.
I was referring to north and south.
Oh, I'm talking about something different then. Carry on.
Okay, so the mass issue is the same reason why we think that comets from the outer solar system, which even 22,000 kilometer orbit, 22,000 year orbit, would still be inside the solar system, just so you know. So, like that comet that said, oh yeah, it's going to come really close to the sun and then fling out. Now, they think it's a comet made of snow and ice because its apparent weight. And its apparent weight is based on its orbit. Now, it's charged based on the sun, therefore it's negative to the sun. So it's coming in, it's negative to the sun, and as it gets closer, it's going through more and more layers like you would on Earth. The sun itself being somewhat of a capacitor, obviously, and an inductor because it has a strong magnetic field. And you're going to fly around that. The electric potential is able to pull material off the sun and vice versa from the comet. Now, the thing is that even 22,000 years won't get you 4 light years. You're not going to get to that other star. So you're still inside the solar system, just really negatively charged compared to the sun. Now here comes 3i Atlas from outside the solar system. Wherever it came from, it is higher electrical potential than the sun. Remember that each sun or each solar system should have a different electrical potential than any other one. And the reason for this is because they are all electrically in different spots. And ground is what we call zero. That's just a name we give it. There is technically no top or bottom to this scale. So if you're coming in from another place, well, you're eventually going to hit a point where your potential is higher than the sun's. And that happened when it got closer, somewhere around our orbit, or maybe Mars. I can't remember. But as soon as it went through that, it started started glowing and spouted a tail towards the sun. That wasn't a fictional tail. It's real because it's positively charged towards the sun. So the tail should go in the other direction. Its mass.
I mentioned that before at the beginning of the stream, that if you look up anti-tail, you'll find that it's an optical illusion. It's not a real tail. It's not real particles that are moving towards the sun.
I think that's what they think, but I don't think that's true. However, it's their explanation. In my case, though,
the anti-tail only happens in the ecliptic of the they only show up in the ecliptic, and Atlas has been spending most of its time in the ecliptic, and that's why we're seeing this anti-tail all the time from the comet. Look it up, dude. I researched
not
it.
Arguing with you. I'm telling you the reason is because that's where the most charge is coming from the sun, the ecliptic. Of course, definitely. That's where it's going to. That's why it's not an illusion.
And the reason why I'm saying it doesn't have a proper tail that's pointing away from the sun and moving away from the sun is because it's mostly made of metal and some rock, but it's not being etched away like normal comets do. That was my point.
I disagree. The material doesn't matter. As I said, any of these bodies could be anything. I mean, besides the sun.
If it's mostly rock, it's being etched away, and then it presents a tail. Because it's it's a negatively charged object that's coming into the inner solar system, which is more positively charged.
It only became glowing when it got out of balance towards the sun. When it was closer to the anode, the sun.
No, it started glowing way far away. It started glowing past the orbit of Saturn as it came.
That is still close to the sun compared to where it's from. It's from another solar system.
Yeah.
But I'm being fair when I say that it could be anything. It doesn't matter. Because what makes a star is that reaction, and we talked about turning it into iron. And that of course requires a lot of charge being processed. Each planet could be a star if we just turn up the charge. We just start cranking the charge. Right. Mercury, Venus, Earth will all start glowing. We'll have trees coming out of the North Pole again. Hands reaching towards the sun. All of this stuff would become apparent. You'd see the fields and everything as ripples, and you wouldn't know what the fuck they were. Sorry, I apologize for swearing. But you would not know what you're looking at, so you would make up a whole whack of stuff about it. That's what we did. And I think that in this case, it appears to be a heavier body simply because it is positively charged to the sun. When it starts getting out of balance to the sun, it starts discharging like the sun discharges in one direction. Well, it's going to discharge in the opposite direction because it is positively charged to the sun, not negative. So that's why it apparently has more mass. The same reason the sun and Earth apparently have lots of iron in them or something because of our mass. But we seem heavy. The sun seems incredibly light, like it's made of hydrogen, but we know it's not. And same with the gas giants. They're not gas. They have a surface. They're just highly charged. Well, that's light. We talked about they're lighter than they should be. Well, this thing's heavier than it should be, but it's still just a rock. It's heavier because, in my opinion, no one's actually really stated this, but basically what I'm suggesting is that there is I've suggested it, but there is a extra addition to the gravitational constant, I would think would be real. And what makes mass is a property of matter. And what makes a mass, however, must have inside of it an charge variable, just like how solid a material is depends on how hot it is, how easy it can break depends on how cold it is. It's that type of thing. So it's a property of matter. Well, it's a property of, if it has a different charge potential, it has a different weight of mass. So this object seems to be heavier because it's coming towards this body, and it appears to be a heavier mass, but there's something that tells me that this is just a now you could be right, could be metal, but we should see a plume coming out of the top and bottom as it's traveling at it's traveling at 67 kilometers a second or some shit. So it is coming north. You should have a plume going north and south along the ecliptic out of the top of it. If that starts being the case, because it will generate a magnetic field like the Earth would, and we should get auroras on it. That it seems to be coming out all over it, so it doesn't seem to have any enough metal to make that. Maybe it's nickel. It could be, but this idea then that this body, therefore, let's just say, doesn't have a magnetic field because it's not making a magnetic field as it's crossing all these electrical fields. So we will say it doesn't. The glowing that happens is it's changing as it's going across these charge potentials, as it's getting quickly going across the Earth, of course, the solar system. And the non-gravitational accelerations are, we've seen, there's a list you can Wikipedia sometime, and I'll show it to you, but they're just a massive list.
Don't forget, these non-gravitational changes in its speed and direction have occurred during the point where it was hit by 4 CMEs. That's a massive amount of charge hitting it.
It's not hit by, it's attracting, or vice versa.
Well, the sun is pushing out these CMEs in its direction, is what I'm saying, and it's being overwhelmed by these charges that it's
actually not
being pushed out at.
That's a misconception, though. That's what I'm trying to tell you. It's not. It's more like a downhill slope than pushing. See, the wind is not really a wind. It's accelerating as it goes. So it's an electric field. That tells you that it is electric field. The body going through it, if it generates magnetic field.
NASA's measured its directions, its motion, and they've stated that it's being pushed forward and sideways.
Right.
So that would make sense if,
of course,
if charge is interacting with it, a massive amount of charge coming off the sun is interacting with it, pushing it well, maybe not pushing it, pulling it.
Well, it's responding to the waves that are created through the plume that came, which would be a bunch of positive charges or whatever. I'm not going to judge what came off the sun. Let me just try to give you an idea of what it is. We
all know what a CME looks like, right? So
of course, that's not what I'm referring to. What I'm trying to tell you is that there's a reason why it appeared to be going forward and appeared to be going to one side. The one side is because, of course, the right-hand rule. And forward is because it's attracted. It's a different charge attracted to these things. It's not like being pushed away from the sun like the other comets are. It's being attracted to it. It's literally going in the opposite. It's going to do everything opposite that the other one does. So it's going to be attracted to the sun. Parts are going to be coming off it, heading towards the sun. because that's the charges that it's giving off. Like it doesn't like the potential of any object is basically like the power of every atom inside of it can be changed and a different zero sum given. And it's no longer a zero sum game. It's now completely differently charged in every body in the system. If it was larger, it would be like, the Venus figurines or something like that. So this is, and of course, the non-gravitational accelerations was first known, if you want to look it up, anyone, it's called the Pioneer anomaly is the first one. And you can see how weird it is because basically it implies that there's some force pulling backwards on this probe, Pioneer. And why is that? But obviously, you can look it up on Thunderbolts as well. The CO2, right. I totally agree 100% of what he's saying. The properties being ripped off this thing, carbon is mixing with it. Could just be a carbon body, for example. Now,
silicon is a form of carbon, isn't it? It has carbon in it.
It would if that's the case, and that actually is a good idea. Actually, what you just said, if it is silicates, rocks, CO2 could occur, but it would require that you give an extra. You'd have to make it solid from silicon. So you'd have to tear it off, turn the silicon into carbon with a nuclear effect. That's not impossible.
We know that's what the solar wind does to comets is it etches them away electrically
etching away electrically and creating
by slamming electrons into
changing elements is a different balling. It's a different thing. But I agree that it's very interesting. I never thought of that before.
It's not impossible, I don't think.
No, that's when you're talking about if it is. This is a whole different body.
To these electrons coming in at.
It's not has nothing to do with that. I mean, okay, I shouldn't be saying it like that. It's just I have a different concept. But basically, if you think of the sun as having giant Earth-sized lightning bolts hitting it all the time, and they're changing a lot of the material into different elements, and some of these things are being flung off the sun. Obviously, they say that all of this stuff came from the sun. Well, why do we have veins of gold and other ores and stuff like that? Well, they're in veins because lightning creates veins. So, but let's not get into this. Let me just answer the last questions. The brightening, 100% true on everything that Drew said there. The brightening is obviously giving it what its apparent shape is, but from what we can guess, but that's why Oumuamua seem to be brightening and dimming, probably because it's processing the electrons like a load, like I said before, that these things do that. The sun has to do that too. The sun's variable, by the way, is 11 years. That's the sunspot cycle is 22 years in full rotation. So if you put that down,
I think it has 106 years too. Another cycle above that.
Well, yes, I think that has to do with everything that's on this shell that we're on. Like all the other stars that are attached to this one lend into its variability. But anyway, it's like hertz, but it's really, really slow. So it'd be like millihertz. Now, the sun plume, that's the big one. And I think that's what it's telling us. It's going in the other direction because of that reasoning. And when it goes around the sun, it's still going to be pointing towards it. And then it's going to go far. It's going to go about the same distance, assuming it doesn't pass any other bodies with a high charge like Jupiter. And if it does, just like the Hale-Bopp comet did that time, it just went to a giant plume, and that's telling you that something's highly charged when suddenly goes to complete plumage. But this is what this body will never see again. And I think that whatever this was, like they could have been like literally cores of another planet that blew apart a while ago. They're not round, though. We know that much because they are having plumes coming off them. If there's any plumes coming off them, then it is, well, that's not unlike what was happening on Venus. When it was ejected, it apparently round, but I mean, you don't understand how round electricity makes things if it has more time. Like, that's why you see the initial pinch gives a bulge around the equator, but the equator is eaten away on a comet.
I was going to say the bulge is usually due to spinning, but the initial pinch is what creates the initial ball.
Well, yes. No, you're absolutely right. But it doesn't have enough time to make it perfectly round.
Well, isn't that why Venus is so round?
Yeah. But in the case of planets, because they're so large, it has the time to do that.
Well, there are certain bodies that don't have that, obviously. Pan.
Well, those are small little moons. They probably were broken apart and spat out of a planet by a thunderbolt.
Well, and you can also see that it has 6 ridges around it. Yeah, it's like a positive lightning bolt. Interestingly, it's only 35 kilometers across, but I was thinking more of, I think it was Oedipus. What was it? IAPT. Wow, whatever it's called.
Iapetus.
That's it. Iapetus. Is this the one that? Yeah, this is the one. Yeah, has this that thing.
The Death Star.
Yeah. No. Well, it has that ridge though.
Yeah, it does look like a Death Star.
It has a huge circle in it just above the.
But remember when I was talking about dust?
Makes it look like the Death Star.
Yeah. Well, no, we were talking about, like I mentioned, about like dust that hits this thing. See, it's not hitting the side. This was being pulled off of something. It went by, and obviously you can see these craters are, excuse me, like just ridges. But this thing hit its neutral point before it was like completely etched, if you know what I mean. Like it must be comfortable with its parent, and been with it for a while. This ridge, however, is from the pinch process that didn't quite finish. And that thing might not look like much, but if you could feel it, like if you knew how big the Earth was, and it would feel like a golf ball, it'd be so smooth, even with the mountains. So we barely have any bumps. Venus, of course, was highly charged inside of a completely different electrical environment, and it is still like the lightning on Venus. If I was not described, like they described it as, where's the light coming from? It's not from the sun in the sky. It's not, because these clouds are so thick, you can't get light through the clouds. The light was coming from near constant lightning. So you can actually look, when you look at like the Venusian pictures, Venera probe pics. Yeah. Venera. Well, it knew what I was talking about. I don't know what I'm saying. Now, this looks kind of weird, but why is it weird? Like it looks kind of wrong. Like it's in a studio or something. I'm not being conspiratorial, but the reason it looks like this is because all of this, there's no shadows except underneath the objects. Like notice this thing out top here. There's nothing out there. Like there's no shadow. The light is
coming from above
everywhere.
Mostly.
No, it's from everywhere. Like every direction had light coming from it. So unless you're right underneath the lip of something, you're going to get light. And that's why it looks so weird, because it was light from every direction. And that's the situation. It was near constant lightning. So material is still being ripped off of this body today, and the atmosphere is incredibly thick. So it's still and hazy. And the reason it's hazy is because of that reason. It's not the material in the air is like raining down rocks all the time. Look at it.
Yeah, I recently heard that the sun stripped away part of Venus's atmosphere recently.
Well, it'll take a while to get through all of it.
Yeah, but if, eventually, you never know. It could become livable, but it would take a while.
Oh, no.
Oops said a spectator has joined.
I personally think that we would have a better chance if I was a smart person, knowing how barren and hellish Mars would be to live on, Venus is a much better place.
Yeah.
And hear me out, though. I mean, floating. Like, you would basically build giant inflatable low pressure things that would basically suspend your city underneath of these giant pontoons, right? And that's how you'd live, and the energy you'd have would be incredible. Because
hot.
Well, it's not just thermal, and besides, you'd be so high up, I don't think it would matter. But it would be the electricity that you could harness, and the atmosphere would be so thick you could just, it would just be very interesting to see. And these wouldn't have to be that big because the atmosphere is so thick. Like, it wouldn't be like something the size of the Hindenburg, to use a bad analogy, would be something that you could just put up there, and it would hold a lot because of how thick the atmosphere is, depending on how low you want to go into it, right? Yeah. Anyway, I'm just thinking of things like that. But that's how weird, it is trying to think of electricity. I was thinking of, I think it was this, what was the picture here? It was this one, I think. Trying to understand how these fields, and these lines don't do any justice to it. That's supposed to be showing you magnetic reconnection, which is the stupidest thing ever.
Mm-hmm.
But
when we know that the auroras are powered directly by the sun, I mean, it's not magnetic reconnection that's causing this.
Well, sure. There's no such thing. I mean, it just simply can't exist.
It's not a magnetic reconnection. It's a flow of electrons being pushed from our plasma to the Earth.
That's fair.
That's
fair,
right?
In a way.
But I'm talking about the pair of Birkeland currents, one on the North Pole, one on the South Pole, that are connected directly to the sun. And those Birkeland currents, earlier there was an image that said millions of amps.
Yeah.
Are coming into the planet. That's not in an hour or in a 24-hour period. That's every second of every day. Millions and millions of amps are being put into this planet.
And amps imply that, yeah.
Yeah, and that's current. That's electric current.
It is, yes.
And we don't see it as it's flowing from the aurora down into the upper atmospheres and lower atmosphere, and then into the ground. We don't see these flow of electrons that are going on, but it's happening.
Well, here's something that should make me reconsider everything. You know how old Göbekli Tepe is? Since we're ending on how crazy it would be if, let's just say, we'll put this in the conspiratorial realm. What would it be like if something that is highly charged as that body hit us? Well, it would. Göbekli Tepe, as you know, is 12,000 years old or so.
Yeah.
And
11,600.
Exactly. Well, but still, you get my idea. 12,000. So 11,600. Well, do you ever notice that it's like Machu Picchu, that it's all these towers being held up by wood, and even the foundations are snapped. This is a reconstruction. So what the towers are from an older culture than them.
You mean the
that
pillars?
they revere? Yeah, the pillars.
Okay, towers.
And the
like,
rocks,
what?
the rocks all around it are just rocks that they put in to build the place again. Like they rebuilt it, like they rebuilt Machu Picchu and stuff.
Yeah.
Yep. They've repurposed.
I mean,
stones for sure. You can see it.
Yes, exactly. I'm gonna get you the idea here, but the reason I wanted you to put this into mental, into mental notation was, if you think about it, this is what they built. Those stones, even that, look at that one right there. It's damaged. It's been snapped right off at the top. So was a few others. So whatever happened here blasted this whole thing down, and they put it back up.
I see.
Which means that these people, this is kind of going to freak you out, okay? I apologize for it. One of two answers to this. Either they are putting back up the remnants of the same culture that we are still looking at in Baalbek and stuff like that, and the ancient Egyptian obelisks and so forth.
Okay, I just wanted to mention to you, Neil, that I subscribe to a fellow called Ancient Architects, and he talks about Göbekli Tepe all the time.
Of course.
Recently, he's put a video out showing that one of these central columns is embedded in one of the walls in one of these places, meaning that pillar, the central columns, was repurposed.
Yeah.
And they built a larger, newer arena. So that's what some of the things have been going on. And older stuff is going to start breaking down and breaking apart, and they're going to have to try and fix it. This
is not breaking apart.
Redoing.
They were blasted to pieces, just like Teotihuacan or Machu Picchu or the pyramids of Tenochtitlan. These were hit by one side blast, lateral blast, an air blast. Hot, that melted stone. You can see them shattered. They were broken off like branches.
Not all of them are like that. There's a lot of them that, that's how this place was noticed. The tip of one of these columns was sticking out of the ground.
I'm not sure if I'm getting through to you. Do you see what you're looking at on the screen? They're just rubble rocks with a bunch of megaliths.
Mm-hmm.
Well, that's what I mean. That's how we would do it if we were kids. Whoever made the monoliths are a different culture than the ones that made the stones and put up the whole thing. The rocks are like they're like Stonehenge.
At the same time.
Well, you
I disagree.
They buried it.
Because that would happen again, and it would blasted to crap. They probably figured it was going to happen. They reburied it.
I see.
I mean, it might not be true. However, I can show you a lot of different stones than this to give you examples of damaged stones at Göbekli Tepe. And you can see that they are literally blasted just like the ones in Pumapunku were, hit and knocked down to one side. So, I mean, don't get me wrong. I'm willing to accept that I am incorrect, but it's very similar in construction. And they did a great job of what they were rebuilding, what they were seeing. So in the sky, look at that like top view. That's a face for sure, sticking out the southern pole or something, right? That's the man. This one over here. This is the great man. the face with the plumage, the feathers that's sticking out of the South Pole. That's what that looks like to me. Or it could be
it looks like it for sure. But
don't get me wrong, I'm not.
Raymond has his ideas about proto-Saturn, and the shape of some of these buildings are shaped like what proto-Saturn went through in different stages as it broke up.
No, I mean, I think that they are depicting either the magnetic field at the bottom of the pole that was sticking out the bottom, but it would require Saturn to be on the other side for that to be the case. However, I'm not going to particularly judge that. What I'm very interested in is the fact that the stones here, the megaliths themselves, okay, the damaged ones or otherwise, are older and are telling a different story than the depiction here. And they couldn't carve into these stones, so they left them as they were and tried to put them in a way that made sense to them. Now, when I'm seeing this and seeing the look at the tops of them with these little things on the top, that's very interesting, because to me that's telling me that this was made the same way.
Yeah.
No, I mean, this is the same technology. Sorry, I don't know what I'm doing.
Well, listen, guys, I gotta go. Have a good night, and we'll talk later.
Yeah, well, we can wrap it up and meet again down the road.
That was wonderful, guys. I very much enjoyed that. I hope I answered some people's questions regarding 3i Atlas. No, it's not a spaceship. Sorry for being mundane, but that's why it's acting weird.
Well, they said it sent a message to Earth. I don't know what that message was, but...
Well, I saw it, and they said it was the Fibonacci sequence, and then, of course, I thought to myself, an interaction between the speed of inductance and the speed of light is about the Fibonacci sequence. But we can study that more about that part later if we find more information about it, because I'm not sure if I buy it 100%. But we'll see.
Yeah, we'll see, yeah. But what do you think about it changing course and speed?
Well, that's the non-gravitational acceleration. We should see that as it goes through different, think about how fast it's going and the fact that it will generate more fields and more magnetic fields as it goes through, let's say, the tail of a Venus, let's say, just for some reason. It will be like a bump and it pushes it slightly to one side, or a blob from the sun is like a hill that sort of pushes it to one side or pulls it, depending on the magnetic and electrical potential that it's, but it's still heavy. Yeah. I mean, it's a mass. It has to move around. It's not, but I think that's the reason why the clockwork universe works. They said it could never work unless there's something in behind sort of tweaking everything as it goes along. Because even today, when we want to get spaceships where we want, we have to sort of tweak it a little bit as it goes. Yeah. We can get it pretty much to the planet, like to the moon, but making a gunshot to hit 3 planets in a row, that requires a little bit of fine adjustments as you're approaching, your planet, like the one, and you have to do this as further it gets out. It takes like 22 minutes to get a response back, right? Every time you touch it. So you have to be sure you get your calculations right.
Yeah.
So I think that they're experiencing the same thing because they think they're going through space, empty space. But as soon as they go near Jupiter, they're passing the electric field of Jupiter, and suddenly they start going up slightly by like 2 inches, and they're like, "What's going on? Why are we moving?"
Yeah.
And they don't know why. And it's okay, but they just went through fields of high electric charge. Look what it's doing to Io, but Io is a lot bigger. You see.
Mm-hmm.
But also, of course, it was because of Io I realized, that's why sulfur means demons.
So it's due to electric effects. Yeah, right.
Yeah. No, it is. It is. I think it's because remember, the only time it can get these motions is when there's a change in the field or current, not something that happens regularly. And remember, we're getting these little pulses, these little ripples are not so bad, but when you hit you're going through the solar system and suddenly it's not like a balloon that you're hitting of Jupiter's coma, but it's going to be thicker because, in a way, it has more electrical potential. As soon as you cross the double layer, suddenly your potential goes from this to suddenly spikes, and that's a big change. So suddenly this rock or this craft, which is quite heavy, all of them are like tons, even a spacecraft.
Yeah.
Even though it looks really small, they're not small. I mean, you can see the Mars rover, the thing's like the size of a car. So, but that's what it's like. So you're hitting these things, and during that change, you end up doing the math on it. You could see the change in potential suddenly with the charge, and then you do the math, and boom, you end up with a little twist to one side and a right-hand rule effect.
Yeah.
It's just, but it's not much, but it's enough to make them wonder why it's happening. But I'm not denying that gravity inertia exists, but I am questioning about whether or not, like I think that they're like, that's why they think they're made of snow because they're so light, but clearly they're not.
Yeah.
And this one is showing exactly what should happen if it comes from a sun or a planet that's highly charged compared to ours.
Yeah.
It's going into the sun and suddenly now it's pulling towards the sun.
Yeah.
That's pretty cool.
Yeah.
I like that I live in a time that I got to see that.
Yeah.
Hey, I got to see Halley's Comet with my own eyes.
Yeah.
So yeah.
That's right. Yeah.
So did you, I think, probably.
My dad lived his whole life in between Halley's Comet. He came the year before he was born, and he died the year before it came back.
No way.
Yeah.
He died in 85?
84. He came back
84.
in 85, right?
Well, 86.
Okay. Well, 2 years.
The reason, well, it's debatable, because we could see it farther away, right?
Yeah.
But they're talking about the naked eye look. But he was born in like 1911?
1912. Yeah.
1912, 2 years from there too.
Yeah.
Because it was, well, think of this way. He's almost Samuel Clemens,
Yeah.
Mark Twain. Because Mark Twain he died in 1910 when the comet came again, and he was born 76 years earlier when Comet Halley came. So there you go.
Yeah, that's interesting. Yeah, well, Neil, thank you so much. It was very fascinating.
I love the conversation. You have a wonderful day, and thank you for asking about my dad.
Oh, you're welcome. I hope you come back soon.
Oh, well, I'm not going anywhere. It's just it takes a little bit of time to get back in the horse, but I feel good. So,
okay.
And I love you all, whoever is still listening.
Too,
take care, friends.
All right. Andy, you still there?
Yeah, I'm still here, Greg.
How you doing?
I'm still here.
Well, I guess we'll wrap it up, and I'll probably play a video from Thornhill, and we'll call it a night. Thanks for coming. You didn't say
much. Then, Greg.
You didn't say much tonight, but.
Oh, well, Neil was pretty well on, and what can you really add?
Yeah, exactly.
He'd done a fair bit of research by the look of it.
Yep.
And his explanations were really good, and it'll be interesting to watch it as it now comes, closer to us. What effects it does, whether we get more earthquakes or volcanoes or anything like that.
Yeah.
Still a fair way to go before it disappears.
Right. Yep.
But no, and I agree with him. No worries. All right then, Greg.
All right.
Catch you later.
We'll see you later. Take care, guys.
Bye. Bye.
Bye-bye.
Bye.
Thank you, spectator, whoever you are. Bye, Angie. All right. That was fun. Always good to have Angie back. I'm going to play a little bit of this video from Thornhill and then call it a night. I hope everybody's doing okay out there. A lot of crap going on in the world. We'll have to talk about that very soon. The whole thing with Israel and Iran and Charlie Kirk, and it's all nuts. And this is kind of an escape from that. So, all right, I'm going to play this last video here from Thornhill. And then I'll have all the links in the description for you. I hope my voice doesn't sound too bad. It seems to be getting better. but it's going to take quite a while. Yeah. Alright, so get the right screen on here and give her a go. Alright, I'm out. I'll see you after the video and then we'll call it a night.
I like this cartoon. It was from the Rolling Stone, and it shows Velikovsky as introducing a touch of the Wild West into celestial dynamics. And that was really the magnet that drew me to Velikovsky. Velikovsky's astrophysics started in his best-selling Worlds in Collision, where he threw down a gauntlet to astronomers, which in earlier centuries, as my friend Dr. Irving Wolfe said, would have had him burned at the stake. His proposal of recent chaos in the planetary system exposed our worst fear, doomsday, the end of the Earth, the end of us. Astronomers who would have happily thrown fuel on the flames boasted that they hadn't read his book because it disobeyed Newton's law of gravity. This was religious dogmatism, not science. However, many scholars did take Velikovsky seriously, I'm pleased to say, and some of those who took him most seriously are at this conference. So this is a kind of a trip down memory lane where I trace my path to where I am now, which may help some of you understand some of the weird stuff that I come out with. I was born during the Second World War, and my father ended up an invalid, I'm afraid. And so he was in and out of a military hospital. Now, while I was in high school, in the sort of midway through, he came home from one of his visits to hospital with a book in his hand, and he said, "I think you might be interested in this." It was that red book there, Worlds in Collision. Well, in primary school, I'd been interested in astronomy to the point where I would memorize facts out of the encyclopedia, draw pictures and go to school and do a show and tell until the kids in my class decided they'd had enough of me and told me in no uncertain terms. But the thing that impressed me with this book was I'd never seen the scientific method applied so broadly. He made leaps from one topic, one discipline to another that I had never seen before. And as it says here, his work crossed over and stimulated new directions of thought in a vast number of academic fields, which alone is no mean feat. But he also showed us, as the Washington Evening Star put it, to not be afraid to stake out new intellectual territory in defiance of fashionable thought. This is from Henry Zecker. He challenged the mysteries of the universe. He sought answers to our most perplexing questions, discovered many, and inspired inquisitive minds to search for more. That alone will mark him as one of the most profoundly influential scholars of the century, perhaps of all time. Now, I read this book, as I said, at high school, and I tried to interest friends there and other students, and I was surprised at how disinterested they seemed to be. So, and also I had this difficulty, how can all of these teachers and people that I've looked up to and all of these encyclopedias I've read be wrong? So wrong. So I kind of let it drift for a few years, and then just before going to university, I read the book again, and I decided, right, the university is the place to ask questions and get answers. Well, my university education disabused me of that idea, because what I found was either the answer I got back was not related to the question I asked, or else I got actual hostility. And that surprised me. It finally meant that I got out of academia. I began postgraduate research, upper atmosphere research, but found that I was being sort of used as slave labour, and decided to leave halfway through the first postgrad year and joined IBM. In those years, it was the Wild West of computing, really, and I got to learn everything, because I never liked being presented with a black box. I had to know how it worked. That was part of my psyche, I think. And so with IBM, I learnt the hardware, the software, the operating system, the compilers, and so on, which eventually led me to being used as the systems engineer for the National University, which, when I look back, was an incredible piece of luck, because this was at the time of the moon landings. And I had access to the professors, the libraries, everything. In those days, they didn't have combination locks and electronic locks on everything, so I could walk freely and ask questions, and it actually had some friends amongst the academic staff. So that's a bit of that background. But after that book was published, of course, there was a furore, and I bought every book that came out. I was impatient to get Velikovsky's next book, and then some of the warriors came to the fore after the AAAS ambush and wrote books, which I also got. C.J. Ransom, who spoke yesterday, his Age of Velikovsky, which was published in 1976, and also Alfred de Grazia compiled a book, The Velikovsky Affair, which is well worth reading, and that was published in 1966. Now, one of the tests of a good hypothesis, because it's not a theory until it's been tested experimentally or observationally, is the more outrageous yet correct a prediction is, the more weight it should carry in favour of that hypothesis. And Velikovsky predicted that Venus had been incandescent only a few thousand years ago. He said, Venus is hot. And this is a small excerpt from a 1964 interview with Eric Larrabee, who was largely responsible, as Dr. Wolf said, for the publication of Worlds in Collision in the face of a lot of opposition.
Now you understand well that I had no personal means to send a marine probe.
If I may be a devil's advocate just momentarily, I know what many of your critics have said is that a prediction like this is a matter of chance, and that they imply that you are pulling things out of the air. Well, obviously, you could have said a great many other things about Venus. You could have said Venus has 2 moons, or is made out of cottage cheese, or something other than saying that it is hot. What led you in particular to say, quite contrary to the belief of the time, that Venus was a hot planet?
Well, first I will say what I said. At the end of my book, in the very last 2 sections, before the section, the end, I put 2 claims. So the position which I selected for them in my book by itself proves the importance I gave to them. These were, first, Venus must be very hot.
Must be hot.
Must be very hot, is very hot. I called the chapter Thermal Balance of Venus. And I said, Venus gives off heat. Not as usually supposed to be, a planet gets so much heat from the sun and reflects so much heat in the space. It gives its own heat. Of course, if it is a body like other bodies in the solar system of 6 billion years or longer, older, Of course, you wouldn't expect that it would give off heat. Now I said also that it was observed by contemporaries of those events and after as an incandescent body. At the same time, still in 1959, it was calculated and accepted that the surface temperature of Venus is 17 degrees Celsius, only about 3 degrees above the temperature of the Earth.
It's very similar to ours.
In 1961, it was found that by radio signals arriving from Venus that it is very hot, actually 600 Fahrenheit.
And your reason for believing this was that your theory required that it be a new planet, a young planet in geological astronomical time.
Yes, it was the cause of the natal heat, but also the result of the short but very stormy history of this body. And let me also say that 600 degree of 1959 was one of the reasons to send the Mariner probe to find that it is not so. I heard a man, scientist from Jet Propulsion Lab, who, speaking before the AAA convention in Philadelphia, expressed his hope that it will be found the temperature much lower. What was found, it was still higher, not 600, but 800 degrees.
Now there is an outrageous yet correct prediction. That alone should have galvanized really curious scientists to investigate his work further. Dr. Irving Wolff talked about what happened in 1974 at the AAAS San Francisco meeting. In that meeting, which was organized as a symposium, Velikovsky's Challenge to Science, it was organized by Professors Donald Goldsmith, Owen Gingerich, Ivan King, and attended by Emanuel Velikovsky and Professors Donald W. Goldsmith, Norman W. Storer, Carl Sagan, J. Darrell Mulholland, and Peter Huber. Fred Schoenemann, who was one of the inner circle, described it as an ill-planned didactic ambush that failed to discredit Velikovsky and actually had an unexpected backlash on his detractors. That was written in an article called A Kick in the Arse. And David Stove, who's an Australian philosopher and also one of the people who doesn't conform, said, we all grizzle about specialisation, professionalisation, departmental empire building, etc. But unless and until you read the details of this case, you can have no idea of the pitiless ferocity or the organisational muscle that organised science can display. That was in an article called The Velikovsky Story, The Scientific Mafia. That other book that's on there, there's two, The Scientists Confront Velikovsky, and the other one is Carl Sagan and Emanuel Velikovsky, which is quite a detailed piece of work by Charles Ginenthal, who was one of Velikovsky's warriors. Now, Carl Sagan did say something about Velikovsky on the program Cosmos. And let me have a look here. It shows a double standard, I think, and also the fact that science is only trivially self-correcting today, or other words, during normal or settled science. You can see that the herd instinct in science is very strong, and this has only been made worse by the global internet type of groupthink amongst them. And the double standard in evidence and scrutiny, one scientist's chosen evidence is another's anathema. Extraordinary claims require only ordinary evidence. Settled science requires a bomb under it to move it. Experts, in my opinion, are the last to know when a fundamental change arrives. The electric universe, for example. But when you look back, all big changes, even the idea of sending rockets to the moon, was said to be impossible by experts. Heavier than air flight was to be impossible. So the last thing you do is ask a grey-haired expert what the future holds, because they will be the last to know. So I show you this now just to get an impression. I think Sagan at this point felt some guilt for what he'd done.
There are many hypotheses in science which are wrong. That's perfectly all right. It's the aperture to finding out what's right. Science is a self-correcting process. To be accepted, new ideas must survive the most rigorous standards of evidence and scrutiny. The worst aspect of the Velikovsky affair is not that many of his ideas were wrong or silly or in gross contradiction to the facts. Rather, the worst aspect is that some scientists attempted to suppress Velikovsky's ideas. The suppression of uncomfortable ideas may be common in religion or in politics, but it is not the path to knowledge, and there's no place for it in the endeavor of science. We do not know beforehand where fundamental insights will arise from about our mysterious and lovely solar system. And the history of our study of the solar system shows clearly that accepted and conventional ideas are often wrong, and that fundamental insights can arise from the most unexpected sources.
Yeah, as I said, Sagan is disingenuous and should have taken his own advice. He was a key suppressor at the 1974 AAAS meeting. Here's an example of what I mean about experts being the last to know when a paradigm shift has begun. In the Scientific American, it says, "We are all impoverished by the selective rejectionism of modern science, all of the taboos in science." In this excerpt, Velikovsky is troubled by the way Ponce reports the San Francisco meeting, and this was shown at the meeting at McMaster University in 1974. I had some information second-hand from Earl Milton, who had some inside information. He said, Velikovsky was assured by the editors of Ponce that Ralph Jurgens would oversee the final report. Usually, Velikovsky lectures without notes. At the San Francisco meeting, he sat to read his paper because he was fearful of omitting important points. He was asked from the floor if any of his predictions had been disproved. He answers he knows of none. Velikovsky is angered that Ponce did not print his response to Sagan's challenge to name which organic compound has a refractive index of 1.44 and has infrared absorption features at 3.4 micrometers and 11.2 micrometers. At the meeting, Velikovsky did answer both questions at length. These were important bits of scientific evidence. Now, this film, shot there in June 1974 at the McMaster meeting, is something that I did on a brand new Kodak 400-foot cartridge sound camera. It was something that Kodak had finally done, that was to introduce sound Super 8 cameras. I had taken I'd built my own radio microphone, but unfortunately it suffered a lot of interference at various times during the meeting, and this is the only one that has good sound, so this has never been seen before.
Why should we create a ghetto for ourselves? Ponce will bring them to those, of course, who have no admittance to answer publication are welcome to Ponce. I hope that Pensée will return to its beginning and be again a strong organ, small in the beginning, but reaching, as we know, the end of the world, and was probably instrument in bringing you today here. And thank you once more. And I will probably say a few words for those, continue what I could not say here, at the banquet this evening. Once more, thank you.
So that was my first meeting with Velikovsky, and you saw the reference to me by coming from the ends of the world. And I have here some photographs taken at that meeting. On the left is Velikovsky standing to answer a question from in the audience. His daughter wrote to me and asked for a copy of that photo, and I sent it to him and received a thank you from him. You can see some of the crowd there. I can just pick out my wife up the back there somewhere, but there are a lot of the warriors visible in some of these photographs. And on the right is Steve Talbot. Now it's interesting that my connection with the Talbots started with Steve, because I had written to him once I knew that this conference was on, and stating what I had done and my interest and so on. And he invited me to sit on one of the panels, so I got to meet people there. And it was there, of course, that I also met Bill Mullen and was very impressed by his opening address. Another shot of the McMaster meeting. There's one of our Scottish scholars sitting in the middle there. He did a lot of work with the Society for Interdisciplinary Studies, which was the UK arm of the Velikovskyan movement, if you like to put it that way. There's many people I can pick out of that, but it gives you some idea of the crowd.
Also sent greetings, Greg J. Purple Heart. Super happy to hear from you, Grinning Cat Face. And I hope you had a wonderful Halloween.
Velikovsky, really, on the scientific side, Ralph Jurgens. I've tried everything I can think of to get more photos of Ralph, but that one was taken at the Grand Canyon. And I've been in touch with a good friend of his was Dr. Earl Milton, a physicist from Lethbridge, Alberta. And I've been in touch with Earl Milton's son, and he's looked through all of the material that he has of his father's, but I've not been able to get another photograph of him, which is a great pity. Earl Milton wrote about him. In 1973 and 1974, Jurgens did yeoman service in preparing Velikovsky for San Francisco while serving as Ponce's physical science gatekeeper. Jurgens served as Velikovsky's research advisor, providing invaluable interpretation which avoided many pitfalls within the sea of commentaries now being made about the state of planet Venus. Ralph also coached the manual about how to present himself when he faces his opponents at San Francisco. This is one of the inspirational things that I got from Ralph Jurgens. If the sun and the stars indeed succeed in fusing lighter elements to form heavier ones, are the relevant activities carried out more or less in plain sight in their atmospheres? Having asked this question, though, Jurgens nevertheless went on to estimate the electrical energy and voltages based on no input from the nuclear process. In other words, if there is nuclear processes going on in the photosphere, he merely calculated the electrical energy required to provide the radiant energy output. Of course, to say this flies in the face of particle physics, because the conditions in that 5,000 degree or so photosphere is not sufficient, of course, to even begin to talk about nuclear fusion, according to standard thinking. He says here, and this was a key to his model and one which is now being tested by SAPPHIRE, the electric sun hypothesis assigns the solar body the role of an anode, that of the higher potential electrode in a cosmical electric discharge. That's the simplicity of the model. And also the genius of Ralph was to identify the fact that all of the detailed features that we actually observe are to be seen in an anode discharge. And of course, the most confronting thing, he said, was the modern astrophysical concept that ascribes the sun's energy to thermonuclear reactions deep inside in the solar interior is contradicted by nearly every observable aspect of the sun. That should have been a huge warning bell in the halls of the academe, but as they say, when you're woken by a loud noise, you get very annoyed. It was a few years later, in 1979, I was working for the Australian government briefly in Washington, DC. And while there, I took the opportunity, my family was with me, I rang Velikovsky at his home and mentioned our meeting in 1974, and I asked whether it would be possible to visit and talk to him about the work that I was interested in. He and his wife graciously had us there on the 29th of April, 1979. And it was there that he, in answer to my question, what is it we don't understand about gravity, he gave me this small pamphlet, Cosmos Without Gravitation. It was a synopsis of a more comprehensive document written from 1941 to 1943. So here I'll give you some of the chapter headings to give you the flavour of what's inside. First of all, and this is fundamental, gravitation is an electromagnetic phenomenon. So now you can see where I got it from. This is where it all started. He gave a list of phenomena not in accord with the theory of gravitation. He looked at the attraction between two atoms, and this is something that had occurred to chemists. The molecular attraction between atoms can sometimes be down to dipole forces. The fact that the atoms are distorted in a molecule gives them one side of the molecule is slightly more positively charged than the other. And this, of course, is a feature of Jerry Pollack's work, where the water molecule is distorted so that one side is more positive than the other. You have a positive and a negative dipole. He covers the attraction of bodies toward the Earth, the time of ascent and descent of a pendulum, because he thought they should be different, and the effect of charge on the weight of a body. If I get a chance, I'll talk about why that idea really doesn't work, but that took a long while to figure out. And of course, his statement that attraction, repulsion, you'll notice, he's talking about repulsion between bodies as well, because a dipole can repel as well as attract. And electromagnetic circumduction act in the solar system. That was his claim. He also covered the anomaly of Mercury and other phenomena, where he tries to explain them. These are some of the phenomena not in accord with the theory of gravitation, according to Velikovsky. Water is 800 times heavier than air, but millions of tons of water droplets are held miles above the ground in clouds. And Jerry Pollack, I think, has shown the way to understand that. Mountains don't exert the pull expected by gravity. That massive rock should attract a plumb bob slightly towards it. It doesn't. So that gave rise to the theory of isostasy, where you have to have a mountain underneath the Earth to kind of balance out the forces so the pendulum actually points towards the centre of the Earth. This is the kind of extremes you have to go to when your theory doesn't really work. Gravity is stronger over oceans than land. The spinning gaseous sun should be oblate. It's almost a perfect sphere. Gravity can't restore orbital perturbations. There is nothing to restore a slight departure from your orbit caused by another body, so that over time the whole thing becomes chaotic. In fact, it has been calculated, I think, by the orbital dynamicists that the solar system should not remain stable for more than a few million years. Beyond that time, it should be destroyed by chaotic behavior. The sweep of a comet's tail around the sun, that's not a gravitation, it's not explained by gravitational effects. And Laplace, he notes, calculated the speed of gravity must be in excess of 50 million times the speed of light. So these are all the keys that I had given to me by Velikovsky. In particular, this is his idea here. Each atom is made up of positive and negative electricity, and though neutral as a whole, and these are his words, may form an electric dipole when subject to an external electric force. Attraction is not due to inherent gravitational properties of matter, I wouldn't say mass, but instead to the well-known electrical properties of attraction. Two dipoles arrange themselves like bar magnets on a slippery surface. If you just throw them on the surface, they'll try and attach north-south, and daisy chain. And they will always swing to try and attract one another. However, and this is the arguments against that simple model, and Velikovsky gave me that document on the basis that it was a preliminary thinking. It certainly had a lot of questions left. If gravity were that simple, an electric field across a polarizable dielectric, that is like in a capacitor, should modify gravity markedly, because there you are, you're distorting the atoms in an electric field. But it doesn't. It does slightly in the Byfield-Brown effect, where a capacitor tends to move in the direction of one of the charged plates. But that doesn't explain gravity. And it should be shielded by a metal conductor, because we're dealing with a bulk electrical field. It isn't. Also, the atomic dipole force is too strong. It's the force that holds molecules together, one of the forces. And if we were held to the Earth like a molecule, we'd be, maybe a few centimetres thick on the surface. So having been given in 1979 the keys, I had what they call the prepared mind. I was on the lookout for a classical physics approach, the kind of approach that got us to the beginning of the 20th century and has given us all of the technology we see now. Very little of the 20th century beyond about the 1920s has contributed much at all to modern technology. It came in a tiny advertisement in the Scientific American in December 1981, and it advertised the Journal of Classical Physics. And the first issue by Ralph Sansbury, who was the originator of this journal, was called Electron Structure. Now, Velikovsky had shown that it was the structure of matter which may give rise to the electric force. And if the electron has structure, that's important. So this was one of the keys. What he did was to repeat the atomic orbital model of smaller charged particles inside the electron and proton. So imagine them as tiny atoms. It's a repeated pattern, a kind of fractal approach to looking at science. And by assuming the electrons have this simple structure, Ralph explained magnetism. He was able to derive Ampere's law just based on this simple model. Most importantly, This model requires for an electron to remain stable that the electric force operates between all of the bits that make up that electron instantly. If there's any delay, then the particles don't know where each other are and the whole thing flies apart. In fact, he calculated that the particles, if they were free to move outside the electron, would travel from here to the far side of the Andromeda galaxy in 1 second. Now, this gives you an idea of the speed of the electric force, and that gives you the idea of the speed of gravity. It also simplified things. Here we have the electric force explains magnetism and gravity. And classical physics was all about simplification, not inventing more and more forces and particles to get a Nobel Prize. It was to try and find out the real nature of matter. And the thing about, or one of the principles I've worked on ever since getting all of these ideas, is that the simpler the model, the more likely it is to be correct. And also, this model provides a real basis for quantum behavior. Cause and effect are reinstated. Quantum theory got rid of cause and effect. Einstein got rid of any means of measuring things because he removed any standards. Between them, the two of them, they got rid of physics. And it also discards the wave-particle duality of light. Ralph did some experiments at great cost to himself, which didn't prove his view of it, but I think it helped me to understand light as a wave motion only. I don't think I'll mess around with this. Einstein's equivalence, where gravitational mass and inertial mass are said to be equivalent, they're not. In fact, even the picture there shows that the guy standing on the Earth is being attracted to all the atoms in the Earth, which means he's being attracted out to the horizon, and from the other side of the Earth, that's nothing like being pushed up in a lift or in a rocket. The equivalence in that diagram is not there. Velikovsky said that the equality of inertial and gravitational mass is a remarkable accidental coincidence in Newton's system. And he's right. It's impossible to adopt Einstein's equivalence principle of inertia and gravity because an outside observer cannot perceive the Earth with all the lifts travelling in different directions. Once again, you've lost your measurement standard of your place in the universe through Einstein's work. Everything's relative. It suggests the equivalence is the same because subatomic electric dipoles are responsible for both the attractive force of gravity and the repulsive force of inertia. It's exactly the same process, so you can expect them to be equivalent once you understand it. Velikovsky said it is probable that besides carrying a charge, the ground turns all of its atoms as dipoles towards the ionosphere. And that's what I've been showing in the last few years in my presentations. Like this. And the result is that you have the positive heavy nuclei drawn towards the centre of mass, and the other pole, the negative poles, facing outwards. And this changes our view of celestial dynamics immediately. But Velikovsky didn't take this step. In fact, it took me decades to take this step because it raises all sorts of other issues. I'm pleased to say that, this infers that the insides of celestial bodies are hollow because you've got a repulsive force pushing outwards and a repulsive force from the rest of the matter in the universe pushing inwards, and the most stable form in that case is a thick spherical shell, which means that we know nothing about what's inside the Earth or the Sun or any other body, or the Moon. I was at various times in my journey in the electric universe, I've come to a point where I've said, oh my God, how am I ever going to tell anyone about this? Because, it's really confronting. It's like going from the flat Earth to the spherical Earth. And it takes time to get over that until I find enough evidence that I feel I can actually give a story which is convincing. And I knew that I had to look for seismic evidence to show that it's a shell and not a solid sphere or even a solid and liquid sphere. Part of the evidence came from the Apollo moon landings, the first ones, where they crashed one of the lunar module back into the moon, having placed a seismometer on the moon. So this was the first seismic experiment on any other body than the Earth. And what was the result? The moon rang like a bell for almost an hour. Well, that one set the geologists back on their heels, because the most obvious answer is that the moon is hollow. But of course they couldn't accept that, so they've made up a really complicated story to try and get around it. But then I came across, somebody sent me a link to work by a South African. He was also in IT, as I had been for all of my career. And he'd come to look at deep earthquakes, because he was interested in the old stories of hollow earth and theories, because they go back hundreds of years. And he found that the best answer to the seismic evidence was that the Earth is a shell, a hollow shell. And when I looked at his evidence, he'd done a very good job of analysing it, and I realised here we have sufficient evidence to really investigate further. You'll notice too that the outside of every celestial body will have a negative pole facing outwards. It's like having the same pole of a magnet in the shape of a sphere. And if you have two of those bodies, you try and push them together, you'll know what it's like trying to push the like poles of magnets together. So all stars and planets in the universe repel each other with an inverse square law. This answered a question that troubled Halton Arp, because his research, which I think is outstanding, showed that the universe is balanced. It's not collapsing, it's not expanding, it seems to be just hanging there, and you can't do that if gravity's pulling everything together. So this answered that question too. Gravity on the cosmic scale is repulsive. Newton's attractive force has a very limited sphere of influence. There is an internal gravitational field that is repulsive, and the interiors of all celestial bodies are not what we think. The solar system, Velikovsky said attraction, repulsion, and electromagnetic circumduction act in the solar system. But of course, Velikovsky was unaware that the plasma shields electric fields, so it's much more complex than that. There was no mention either of how you establish feedback to have settled the solar system down from a chaotic state just a few thousand years ago to the present clockwork order. The sun, pardon me, planets and satellites, comets are all charged bodies and are interdependent. This is Velikovsky once again. The sun is charged negatively with respect to the Earth. Now this statement is incorrect because of Jurgen's later work. The sun is a magnet. The form of the corona suggests a strong magnetic field. Well, Velikovsky was the first one to talk about magnetism on other bodies, really with any coherent hypothesis to back it. But he said the sun's charge and rotation must produce a strong magnetic field because a rotating charged body must produce a dipole magnetic field. That's been dismissed because when they calculate how much charge you need, they say, oh, it's impossible. But they're using plain electrostatics. Forget plasma. The charged planets move as charged bodies at right angles to the sun's magnetic field. That's what he thought. In other words, it was more like electric motor than... and this is the point. Pardon me. Gravity exists, and gravity is a special form of the electric force, almost identical to magnetism, It's just that those two forces are created under different circumstances, one at the free subatomic level and the other one trapped in an atom. But they're identical to that extent. Now, the big journey came when the Saturn story came up, because I read Dave Talbot's book, published in 1980 as soon as it came out, and Eduardo Cardona had been an inspiration to me ever since the Kronos and Ponce articles began to be published. And it was in the fall of 1977 in Kronos 3, number 1, Eduardo published The Son of Night, which referred to Saturn, which caught my attention, of course. And Eduardo's research was sufficiently well documented and thought through that I used his findings as a basis for trying to understand the history of the solar system, the recent history, because I wanted to know, where did Venus come from? Where did the Earth come from? Where did Mars come from? What had happened? And could it be explained in proper classical physics? So he and I corresponded quite a lot, and he published many of my articles in Kronos. So the two of us, this is where myth can become science, instead of, as we have now, science becoming myth. And the resulting cosmological picture that emerged had to be simple and coherent. But as it turns out, the story that unfolded would make 2001: A Space Odyssey look like child's play. I'd love to see this work in an IMAX theatre. Dr. Earl Milton was a good friend and visited us at the time of Halley's Comet appearance and stayed with us in Canberra. I took this photo in 1983. I'd been posted by the government to London twice, which was very unusual, in the 80s, and I had Earl invited to speak to the SIS group over there. It was with the SIS group that I began my first writing of articles and having them published. In 1980, he and Jurgens independently concluded that a comet nucleus would be scarred, and this is a direct quote, like an electrode in an arc. Over time, the cometary nucleus should become cratered and pitted. When a spacecraft finally achieves a rendezvous with one of the comets, scientists are going to be surprised to find a surface pitted like that of the Moon, Mars, or Mercury. And that was written at the time when scientists had never seen a comet's surface. The first flyby took place 6 years later. In England, I caught up with Eric Crew, who was a disciple of Charles Bruce. And you'd be surprised, this is one of the things that continues to surprise me, is that there seems to be no new ideas under the sun, because you find that people in the past have had the same ideas, but they've only gone so far and not put the whole picture together, which I see as my job, is putting the big picture together. Dr. Bruce's lightning research with the Electrical Research Association and the attendance at Sidney Chapman's 1941 Kelvin lecture on the sun led to the application of these ideas to cosmic phenomena and to a new all-electric universe. Charles Bruce wrote, "The surfaces of stars can be explained as lightning discharges which are observed in the atmosphere of the Earth." In 1944, I was only a toddler then, Bruce wrote, "In fact, it may well be that both Jupiter and Saturn were at one time minor stars and that their satellite systems were formed as the result of minor or planetary nova outbursts." Well, I couldn't have said it better myself. Eric did a lot of work trying to get Bruce acknowledged for his work. And I only missed seeing him on one of my occasions in England. I realised before he died, which was unfortunate. I've managed to meet most of the people I wanted to see because the job took me around the world very often. Now, in 1994, and this is 20 years after the Portland meeting, after the McMaster meeting, Dave Talbot put on an international conference. called Velikovsky, Ancient Myth and Modern Science. And this is where I saw Dave's presentation. He missed mine. I was talking about Velikovsky and the evidence for it having been recently born. And I said to him, I think we should join forces because our combined story is far more powerful than either one of us alone. I've still got a little to go with a film that might be of interest, if I've got time. Okay. Mel and Amy Aitchison were amongst the first people I met when I went back in 1996, December, and camped on Dave's office floor for a month, and then we put on a meeting in Portland in 1997. Mel and Amy introduced me to Halton Arp, and that was an inspiration, another inspiration. And then in May 2000, Halton Arp spoke at our conference along with Tony Pratt, whom you've heard a lot about, and it was a historic event. More important, I would say, than the Solvay conference all those decades earlier. Halton Arp's views on cosmology, published in Seeing Red, set the goalposts for electric universe cosmology. I'd done a lot of work on the sun and the solar system. This painted the bigger picture, and the whole thing became a more coherent cosmology. This is Tony Pratt and I. The quest to understand Velikovsky's electrified cosmos led to plasma cosmology, a subject ignored by astrophysicists despite its engineering heritage and successful predictions. It was a critical juncture when Tony joined us at the request of Dave Talbot for our conference in May 2000. Tony's research gave us the opportunity to verify the convergence of the mytho-historical record with high-energy electrical discharges in space plasma. And this is some film of the historic Portland meeting.
Gravity changed, but gravity changing won't
alter
the insurmountable problem you see in angular momentum.
It wouldn't, and in fact, the angular momentum problem for is so severe that...
Maybe you could just take a minute to explain why you don't see any way that orbits can be circularized quickly. In other words, I mentioned,
Michael
for
Armstrong.
instance, it was just a numerical simulation.
Cardona.
They disturbed one of the gas giants, and then two of them exchanged orbits, and they circularized within 1,000 years. This was reported.
So when we do a simulation,
this was the aha moment.
We're stuck when we assign one numerical parameter, all dead because they're frozen in. So I mean, we've got no wiggle room. Yeah. Anyway, that's.
We see the RRR big objects, galaxies with ejections along the line, and we see older galaxies along the same line. The way around the angular momentum problem is that if they come out this way without any component, they only go up and down, and they stay along that line. So that I think we have perfectly good empirical evidence for objects being formed along the line and staying along that line.
The data creates patterns that have to be explained. I mean, this configuration, as it has been reconstructed up to this point, has some incredibly specific components and interactions between them. And it is, in fact, actually at that level of greater deal that the power of the model itself just begins to flower. And it becomes extremely compelling because it's so specific. The relationships are so specific, and it's so ludicrous. How could it possibly be confirmed? But you know exactly what needs to be confirmed because it's defined by these relationships. You go and you look, and there it is. And it's a puzzle for the... I mean, we have gone through this 1,000 times. Ev and I we would on the phone, and we would have these incredible experiences. Just the things we look for, once we can identify what should be found, they'll be found.
I have one more little clip to show, and this was at an SIS meeting in London where Tony and I were speaking. I was talking on the electric universe and the Saturn configuration, or how to explain the impossible. I was followed by Tony Pratt on the origins of icons from antiquity.
It was very refreshing to listen to Wall's talk on the electric universe, and I guess I played a role, somewhat of a role in establishing what is called the plasma universe, which is about the same thing. Very refreshing to see that as a field that I worked in for, gosh, 2.5 decades or so, and right now I'm working in something very closely related, but it's different. It's petroglyphs. Okay, it's not galaxies. Rotation, magnetic fields, and galaxies, which we produced, which is on our websites or in any number of publications. But it's carvings on rock by man in prehistory. Now, why are these important? This is a picture that I took on the Navajo reservation, and which is absolutely typical of petroglyphs that one will find around the world. As I'm going to show, petroglyphs have a definite orientation. They also change in morphology and shape depending on the latitude that they're found on Earth. And this is typically, this is at about 36 degrees latitude north, so it's lower than the United Kingdom. But perfectly typical around the Earth, and the duck-shaped heads appear everywhere as well as these other symbols that I'm going to go into why. My first introduction to petroglyphs was by David Talbot. I went to a meeting of his by accident and learned something about what they were doing, and then he showed me some pictures, and I looked at the pictures, and I said, "Where did you get these pictures?" Because I had never seen them outside of an unclassified environment. And they're on rocks. They're on rocks. Where are these rocks stored? What, a vault? Rocks. And I was kind of, what am I going to do now?
I'll leave it there. Thank you, Bill.
That's going to do it for me tonight, guys. I love you a lot. Be good to each other. And I'll see you next week. Take care. I'll see you on down the road.